Hello everyone, my name is Jamie and I'm a Chegg tutor, and I'm going to go over a short tutorial talking about the definition of phase and vertical shifts. So for this instance, I'm just going to talk about a sine wave. And what I've got here is an equation, a sine of bx plus c plus d. And all of these, capital letters are constants. They're not any variables, they're not any functions of x. We're just going to see how these variations shift or elongate or, squish our original sine graph. So the original sine graph that we usually see is dictated right here, or depicted right here. So in that case, a will be equal to 1, and b will be equal to 1, and c and d will be equal to 0. So you've got your general, f of x is equal to sine of x. Typical equation we usually see. So there we go. I've got my graph right there. And the y-axis, of course, ranges from -1 to 1. And then x goes continuously from this interval is pi over 2, pi, 3 pi over 2 to 2 pi, and on and so on. So what I'm going to do is I'm going to change each one of these constants one by one and see how it affects this original graph that I have here. Almost like a science experiment, keeping everything constant and just changing one variable. Well, that's what I'm going to do. So right here, I made my a equal to 2. And I kept b equal to 1, c equal to 0, and d equal to 0. So my equation for this graph is, let me change the color, f of x is equal to 2 sine of x. So if you think about it, it's just basically this equation times 2. So every value that you have here, you literally just take that value. Let's say, we'll start with pi over 2 because that's easy. Y is equal to 1, so you literally just multiply that by 2. And all of these, not so nice answers, you've got like long decimals right there, are just multiplied by 2. They're all just shifted up in a sense. But all the zeros, of course, 0 times 2 is 0, so they stay put. So that's all you did. You elongated the chart. So of course, if I were to make a equal to 1/2, then it would shorten the chart and make it, like a little bitty curves inside here. So now going on, I then changed my b component and I made it equal to 3. So now my equation looks like this. F of x is equal to sine of 3x. So what happens here is my period changes. Now I tried to show this. It's a little bit difficult with these, big markers. But what actually happens is that, as you can see, the period becomes smaller and these oscillations happen more frequently than over here. So let's think about this for a second. So let's make this equal to question mark. So when does the sign of question mark equal 1? Well, in this graph, question mark has to be pi over 2. And then, various values, pi over 2 plus 2 pi, through the various periods. But let's just go with pi over 2. So my question mark is equal to 3x. So in that case, my x would just be 1 because there was no 3. In this case, my x is going to be 1/3 of this value. Pi over 6. So what that means is instead of 1 being here at pi over 2, it happens quicker. So that means that this period and all the values in between reach their values quicker than this graph by a factor of 3. So, moving on. In this case, I made my c equal to 1. So I've got f of x is equal to sine of x plus 1. Go. So that means the graph gets shifted by 1 to the left. So let's think about this. You're adding 1. You would think that it goes to the right. But let's look at this. So let's say we make x equal to 0. So on this graph, the sign of 1 would be about here. So at x is equal to 0, which is this line right, whoa, it's a terrible line. Okay, at this line right here, it has a value, sine of 1, which is right here. So if you think about it, you have this number right here that's being put right there. So since it got moved over, so does everything else. So at this point, when sine of x is equal to 0, this is equal to 0. When x is equal to 0, sine of x is equal to 1. So everything moves to the left. Think about that, you'll never go wrong. So now we've got here, d is equal to 2. That means f of x is equal to sine of x. Then outside the parentheses, I have plus 2. So let's relate that to this graph I have here. And I have, so sine of x, let's make x equal to 0. You have 0. So you have 0 plus 2. So now at x equal to 0, my function equals 2. So you shift everything up. So here we would have at pi over 2, sine of x equals 1, or sine of pi over 2 equals 1. So then we would make sine of pi over 2 plus 2 equals 3. So let's look back at all of these. So this changing a elongates or shortens the graph, but the period stays the same. Changing b does not affect the y-axis like this one, but it changes the period. It shrinks or elongates the graph. This one here does not change the period or the y-axis, but it shifts either left or right, depending on if this is positive or negative. And this one changes the y-axis, but not the period, and literally just shifts it up or down. So let's put all of this knowledge into an equation, or in a problem. Now we have 3 times sine of x plus 2. So we can either, so we're going to take our original graph. So let me just draw sine of x, because we're always going to relate it to this, because we know what this one looks like. Like that. So we're going to take that graph, and we're either going to elongate it by 3 first, or we're going to shift it to the left by 2 first. Either way, you can arrive at the same answer. So we're going to shift this graph to the left, by 2. Sorry. Here we go. And then we're gonna elongate it. Whoa. Elongate it by 3. We're just gonna, oh, my bad. It's not gonna hit the center because we shifted it. It's gonna look more or less like that. If I had actual graph paper, that would help. But the idea is still there, the whole shifting and elongating. So I hope that helped. So keep on studying, work hard, and hope this helped with any questions. Thank you.